Next, I want to discuss subtraction of integers. So when it comes to subtraction of integers, there are a couple different methods to consider. The first of which I want to talk about is the takeaway method, and that'll be the most familiar to you. So if I wanted to do 6 minus 2, of course we know that's equal to 4. So how do we model this? So we can model the number 6 with just 6 positive chips, and then minus 2, that means that we take away 2 positive chips. So we take away 2 of the positive chips, and then we will be left with 4 positive chips here. Okay, and we could do something similar when it comes to subtracting negative integers. So if I wanted to do -4 minus -1, we start with 4 negative chips, and then we take away 1 of those negative chips, and we're left with 3 of those negative chips. And because we end up with 3 negative chips, we would say that this equals -3. Okay, so note that over here we're subtracting a positive number, and down here we're subtracting a negative number. So when we subtract a positive number, we have to get rid of positive chips. When we subtract a negative number, we have to get rid of negative chips. Okay, and that's key when it comes to the next method, which is adding the opposite. And this is when we start combining positive and negative numbers in our subtraction problem. So if I wanted to do 4 minus -2, I start with a model for 4, and then I want to take away -2. So here's a model for just positive 4. I have 4 positive chips. And when I subtract -2, what I need to do is I need to take away 2 negative chips. But using this model, there aren't any negative chips to take away. So what I have to do instead is add 2 negative chips in the form of a canceling pair so that I still am modeling the number 4. So this right here is also a model for the number 4. So these represent the same number because of these canceling pairs here. And so we add 2 of the canceling pairs so that we can cancel, or so that we can take away 2 of the negative chips. And so effectively what we've done is we've added the opposite of -2. So we've added +2. When we took away 2 negative chips to do that. So this is equal to +6. More specifically, it's equal to 4 plus 2. This is like what I mean by adding the opposite. So instead of subtracting -2, we're adding +2, which of course is 6. Okay. Now if I want to do, instead of positive minus negative, I wanted to do a negative number minus a positive number, same sort of thing will apply. So here I start with 4 negative chips, and I want to take away 2 positive chips, right? So I start with 4 negative chips, and then I introduce 2 of these canceling pairs so that I can take away 2 of the positive chips. And so effectively, we have, after we've taken away the 2 positive chips, we have effectively added 2 of the negative chips. So we've added the opposite of +2, which is leaving us with -6. All right. So this is kind of -4 plus -2. You could think of it that way. This is a little bit more confusing to think of it that way than it is over here, but again, the model is very similar. All right, last approach is the number line approach. So if I want to do just 4 minus 2, we could use arrows for this. So here's 4, and then here is 2. Remember, we just start with, we draw arrows starting at 0, pointing towards whatever the number is. And so if I want to add 4 plus 2, then I would do start with 4, and then basically just take the arrow for 2 and then just tack that onto the end of it. Whereas if I wanted to subtract 2 instead, you basically just reverse this arrow and then tack that onto the end of it. Okay, so we go 4 this way and then 2 in the opposite direction. So a little bit of adding the opposite going on here. And we end up at 2. Okay, and it's important to note that the final answer is just going to end up equaling the distance from 2 to 4 on the number line when we do and that's specifically when we do a bigger number minus a smaller number. Okay, when we do a smaller number minus a bigger number, we have to be a little bit more careful. All right, let's start introducing some integers in here. So 4 minus -3. So here's 4 all the way over here and -3 all the way over here. So again, bigger number minus smaller number. In these situations, bigger number minus smaller number is going to equal the distance between those two numbers, which we can see, we can split it up as 4 plus 3. So this is 4 plus 3. Again, another adding the opposite sort of situation. And so this distance is equal to 7. Okay. Now, this is when it's a bigger number minus a smaller number. If I wanted to instead reverse the order here, like -3 minus +4, instead, this is not going to equal the distance from -3 to +4. It's going to end up being the negative of that distance. And so for this reason, thinking of like one number minus another number, or subtraction of integers just as a distance might not always be the best model, especially for students that are having trouble understanding when is this supposed to be positive, when is it supposed to be negative. So here's an alternate approach that you could take here. So if I wanted to do -3 minus +4 instead, another thing that you could do is, so start with your model for -3, and your model for +4 would look like this. And so you could just tack on the opposite of +4, which would just be going to the left 4 units. So we go left 3 and then left 4, and then we end up getting -7. So the arrow approach here is a little bit better for this situation. And so how can we use the arrow approach for something like 4 minus -3, like our original problem here? So 4 minus -3, so here's -3, here's +4. What we want to do is we want to start with +4, and then we want to add the opposite of -3. So instead of going left 3 to represent like adding -3, we want to go the opposite of that in 3 units. Okay, so we go right 4, and then we tack on the opposite of -3, which is this right here. And so this ends up giving us 7. So 4 minus -3 gives us 7. Okay. All right, so that's all. Thank you for listening.